Mm-hmm.
And then the last one is equilateral.
Equilateral. I
Yeah.
haven't heard of that.
Okay. Now you will, and actually none of this really matters for the stuff that I want to do today, but I wanted you to see the words because we will be working on right triangles today. Yeah, we'll leave it at that. That's great. So do you know anything else about a triangle? Do you remember any other things that you want to say? Hey, Matthew, I remember this about a triangle.
Yeah, triangle. That is a right triangle.
That's a right triangle. Yeah. Do you remember what this is called over here that I'm pointing at? It's a
Uh,
side, but there's another word for it. Like they're all sides.
okay, I think that is isosceles.
It is. This one actually is an isosceles right triangle. And that's because these two sides are the same. Sides, right? Sides. But the
Mhm.
third side is often called the hypotenuse. Have you heard that before?
No.
Okay, so that's the third side. Sometimes the sides, when they're coming out from the 90-degree, they're called legs. Now, if we were to
Mhm.
rotate the triangle, I don't know if this makes any sense or not, but could you imagine how these are legs
Yeah, they are legs,
for
but
a stick
and
figure?
one of them is going to be the scalene.
Well, can you visually see why these are the legs? Like, I think the idea is that there's a
Okay,
person
I think
here.
that's a scalene triangle.
Well, it's actually a right triangle. It's got the right angle there. It's a right
Mm.
isosceles triangle. But visually, is
The
that
right,
kind of a
that's the isosceles right triangle, right?
yes. But they have two legs and a hypotenuse. So the hypotenuse is always across from the 90-degree angle.
Okay.
Yeah, so we don't need to talk a lot about like definitions and stuff, but what we do need to do is learn how to find the lengths of sides in a triangle. So I'm going to pull up a problem here from a worksheet that I think will be very helpful for us today. So I'm going to put this picture on the screen here. And it says if A equals 3 and B equals 4, solve for C.
Okay.
And so if I were to just get rid of this is really 3, this is really 4, we want to find the value of C. Okay. And to do that, we're going to use what's called the Pythagorean theorem. Okay.
Okay.
So the
Mhm.
Pythagorean theorem says a squared plus b squared equals c squared. Have you seen that before?
Yeah, I remember that.
Good. Now I'm going to put the numbers below the letters. That way we've got the values here. So a
Mhm.
squared is 3, or a is 3, b is 4, and we don't know c.
Mhm.
What is the value of 3 squared?
Okay.
What is the value of 3 squared? What is 3 times 3?
9.
9. Plus, what is 4 squared?
That is going to be 16.
Okay. What is 9 plus 16? Let me know when you're ready.
Yeah,
What is 9 plus 16?
25.
25. So this equation right here, what this says, it says that some number, c times c is really 25. It means the same number times itself is 25. Can you think of that number? That number, when you multiply it by itself, you get 25. Can you think of that?
Okay, so you multiply that and c times c, that is going to be 25 squared.
Well, whatever C times C is, it has to equal 25.
Five.
Yes, because 5 times 5 is 25. So the third side, C, is 5. Isn't that
Mhm.
nice?
Yeah.
Yeah, that's really cool. Okay, let's do another one. You ready to do another one?
Hmm.
All right. Let's do another one here. Okay, so I'm gonna all right, so this one says if A equals 6 and B equals 8, solve for C. So what is the value of A?
The value of A.
Yes,
Okay, the value of A. All right, that value of A is 6, and the
and
value of
B,
B is 8.
good. And the Pythagorean theorem says A squared plus
8
B
squared
squared,
plus 6 squared.
yes, equals C squared. So 8, well, actually A is 6. Let me put that value in. 6 squared plus 8 squared equals C squared.
Hmm.
What is 6 squared? What is 6 times 6?
6 times 6.
Yes, yes.
All right, so 6 times 6 is 36, and 8 times 8 is 64.
Good. What is 36 plus 64?
100. That's equals 10.
C is equal to 10. Yeah. So this is 10. Good. Good. That's great. I'm really pleased that you're able to work that out on your own.
Yeah.
All right, let's look at another problem here.
Hmm.
This time it says if A equals 5 and B equals 12, solve for C.
A is, all right, A is 5, B is 12. So 5 times 5 is 25. 12 times 12 is 144.
Yeah, so what I would love to see you do, and this is what I think is going to give you the best chance to help you, is writing the equation down each time. And then, like you said, 5 squared plus 12 squared.
Hmm.
What is 5 squared?
5 squared.
Yes,
5 squared. That is 25.
it is 25
12 times
plus,
12 is 144.
okay. What is 25 plus 144?
Okay, that ran 25 plus 144. 169. And that is 13.
Yes, perfect.
Yes.
Yeah, you're really picking this up. That's awesome. That's really good. Okay. I'm going to throw something just slightly different at you. I really want us to have success here. Yeah, let's give it a try. We'll just see how it goes. So in this problem,
Hmm.
let me grab this problem here. In this problem, they're giving you A and C.
Okay.
So notice in the previous problems, I gave you the 2 legs.
Okay.
Here, I'm not giving you the legs. I'm giving you one leg and the hypotenuse.
Okay.
So let me write the equation again. A squared plus B squared equals C squared. I'm giving you A, but I'm not giving you B. I am giving you C. Do you see how that's slightly different?
Yeah. Wait a minute. Yeah, B squared, I think it needs to be 1 squared.
We don't have a value for B. So here, what's different is we need to figure out 5 squared. What is 5 squared?
25.
Okay. What is 13 squared?
13 squared.
Yeah,
That
what
is
13 times 13.
169.
Okay. Now watch this. We're going to subtract 25 from both sides. So B squared equals 144. So the question again is what number times itself, like B times B, has to equal
It's
1?
12.
B is 12. Good. That's awesome. That's really good. It's very hard for students to understand what we're doing here. So I'm glad you're picking it up quickly. Let's look at another problem.
Okay.
So this time they're giving you A. They're saying A is 15. C is 17.
Yeah.
Okay. And then B. B this time we don't know. But the equation is, what's the equation I've been writing in every single problem? What?
Okay. So
What
now
is
for that right there,
Yeah,
solve
what
for
is
B.
yeah, but what's the Pythagorean theorem? What have
15
I been?
squared plus 17 squared.
You got to write it this way. A squared plus B squared equals C squared. You got to write it this way.
Okay. All right.
What is the value of A?
The value of A.
Yep. What's the value of A in this problem?
The value of A. Okay. The value of A is 15 squared.
Well, it's 15 and then you square it.
Yeah.
Okay. Plus B squared. I don't know B. That's what I'm trying to find. What's the value of C?
Okay. So 15 squared plus B squared equals
C. What's the value of C?
17 squared.
17 squared. Okay. So what is 15 squared?
15 squared.
Yes. And if you're not sure, you can either use a calculator, you can go off to the side here and do 15 times 15, but it's very important that you be able to figure that out.
Okay. Okay, 15 times 15, that is 225.
Good. And 17 squared. 17 times 17. What is that?
17 times 17.
Yes. Again, like if you need to, you can go off to the side or you can grab a calculator.
Okay. So now in here, 225 plus B squared, you're saying?
Yep. I'm waiting on you to tell me
17
what
times
is.
17. Okay.
Yes,
Okay.
yes, exactly. And you're welcome to use a calculator or do it by hand. Either way is fine. You got to get the right number though.
289.
Good. Now, in all the previous problems, whichever one's the number, we move it to the left. How do we move? What do we do to move this number to the right? We need to move it right.
Mhm.
And we can go back and look here. What did I do to the 25? How did I move it right? What's the math operation here?
The math operation.
Yes. What am I doing right here? What am I trying to draw your attention to?
Okay, the math operation 25 minus 25 is 0.
You subtract 25. So
Mhm.
down here, what are you going to subtract? What number do you subtract?
Number I subtract.
Yes. I'm trying to help you out here by pointing to it.
Okay, 225 plus b squared. That is going to be okay. So you have to subtract by 225 by 289.
You subtract 225 on both sides of the equation.
Yeah.
Okay, so b squared equals, what is 289 subtract 225? And again, I'm okay if you want to use a calculator, like that's not the point here.
Okay. Okay. B squared. Okay.
What is 289 minus 225?
64.
64. So now what number b times b gives you 64? What number times itself gives you 64?
Gives you 64.
Yes. What number times itself gives you 64?
Number times a number gives you 64. Number times the number gives you 64. Okay. That is going to be all right. 8.
Yes, b is equal to 8. Perfect.
Mm-hmm.
Very good. Okay, let's do another problem here. Do you need a short break?
Yeah, of course.
Okay, I'll check in with you at 7:24.
All right.
All right, Sourish, are you ready to do a little bit more here?
Am I ready to do a little more?
Yeah.
Yeah, yeah.
All right. All right, so here's a I think we just did this problem. Yeah, sorry about that. Let me grab the next problem here I want us to work on. Sorry about that. Okay, here we go.
Mm-hmm.
So again, I'm giving you in all of these problems, I'm giving you 2 of the 3 sides. 2 of the 3 sides. So here I'm giving you B is 8, and C is 10, and I'm going to solve for A. And what is the equation that we've been using over and over again? I need you to tell me the equation we've been using over and over again.
Okay.
What is the equation that we've used in every single problem tonight?
Okay. All right. So now right there. Okay. So now for A, you need to just solve for A, right? So 8 squared is 64.
I'm asking you for the equation, Sourish. We've used it in every single problem tonight. I can scroll up if you want, but you've got to know this equation that we've been using over and over again.
Okay.
So what is the equation? If you've been taking notes, it should be written in your notes for every single problem.
Okay. So 8 squared is 64. 10 squared is 100.
No, Sourish, let's go back. Let's go back. What did I box in?
8 squared, A squared plus B squared equals C squared.
Yes, and that's what I'm asking you to tell me. I'm asking you to tell me this equation. This is called the Pythagorean theorem. You don't need to know that it's Pythagorean theorem, but you need to know that it's A squared plus B squared equals C squared. And that's what I'm asking you to do. Because look in the next problem. What equation did we use in the next problem?
Okay. So A squared plus B squared equals C squared.
Right. So when you're practicing tennis, and I've played tennis, I've practiced tennis before. When I'm trying to hit a shot like a forehand, and like if I don't have someone feeding me balls, I use a ball machine, and I have to hit the same shot over and over and over again. That's the only way I can figure out how to hit a backhand or a forehand. And that's what I'm asking you to do here. I'm asking you to, like, over and over again, tell me this equation. Because this equation is used throughout geometry, and I want you to know it so well that you can repeat it, at any time. A squared plus B squared equals C squared. Again, look at the next problem we did. What is the equation that we used?
A squared plus B squared equals C squared.
Exactly. So in this problem, what I'm asking you is, what equation are we going to use? You're going to say A squared plus B squared equals C squared. And then you put the numbers in.
8 squared.
We don't know A. Remember, A is unknown.
Okay, B squared.
What is B? B is
8 squared.
It is 8, and then you square it. What is C?
10 squared.
10, and then you square it. What is 8 squared? What is 8 times 8?
8 times 8, 64.
Okay. What is 10 squared? What is 10 times 10?
10 times 10.
What is 10 times 10?
10 times 10.
Yes.
10 times 10 is 100.
Okay. Now notice that we have the variable on this side, a number with it. How do we move the number to the right? How do we move this 64 to the right? What's the math operation?
Okay. So for that right there, so okay, 64 and 100, you need to just subtract by 64 on both sides.
Exactly. Yes, perfectly said.
Mhm.
What is 100 minus 64?
100 minus 64.
Yes.
$36.
36. Perfect. Okay, now what number times itself is 36?
One number that equals 36.
What number times itself,
Yep,
right?
that is
A
gonna
times
be,
A.
that is gonna be 6.
A is 6. Perfect. Good.
Mm-hmm.
Okay. All right. I've got a problem here, and this could be, I mean, this could be our last problem. I'd like to do more, but I want to see if you can do one on your own. Like that's what this is all about, Sourish. It's probably no different than tennis, like you practice, 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 and like I'm not going to be there. Your instructor's not going to be there. Like, can you do a problem like this on your own? That's what I'm hoping to see here.
Mm-hmm.
So I'm going to give you until 7:33,
Yeah.
and I'm going to just check back in with you and see how you're doing. Okay.
Okay.
All right. Hey, Sourish, how are you doing on this problem?
I'm doing good. I'm doing good. I'm just, I figured it out. Okay. I think I figured it out. Okay.
Do
So
you have a
okay. A squared, plus, A squared, A squared, no, plus B squared equals C squared. And that's going to be 12 squared plus B squared equals equals 15 squared.
good, good. That's a great
12 times
start.
12 is 144. 15 times 15 is 225.
Great.
Subtract by both sides by 144.
Wow, this is awesome. Keep going. B squared equals
Yeah.
so what's 225
So
minus
yeah,
one?
yeah, I'm subtracting it.
Oh, cool. Wow, you're kicking this problem's butt. Yeah, keep going.
Mm-hmm. 81, and it's gonna be 9.
B is 9. Wow. That was really good. I'm really impressed, Sarish. Did you find
Mm-hmm.
that problem to be easy, difficult, medium? What do you think?
I found. I think I learned that from you. That's why.
No, no, you did that. That was all on you.
Yeah, I know.
That's fantastic. That is fantastic.
Yep.
Wow. I mean, I just did, you
So
worked this.
what is this lesson called, by the way?
This is the Pythagorean theorem.
Pythagorean Theorem.
Yep.
That's
But
going to
then,
be in 10th grade geometry.
yes, sir. Yes, you're going to see that. Yeah. But this is great. You know, you should be very, very proud of yourself here. Let's just spend a few more minutes. We're not necessarily going to do any more triangle problems, but I want to just review a couple of concepts with you that we've
Okay.
already talked about today. So like 6 squared means 6 times 6. Do you agree with that?
Yeah.
What is 12 divided by 2?
6.
It's 6, right? But let's say we square it. That
Mhm.
means it's 12 divided by 2 times
Mhm.
12 divided by 2. What is 12 times 12?
12 times 12.
Yes.
144.
Good. 2 times 2
2 times 2.
is 4.
Yeah.
144 divided by 4 is 36, which is the same as 6 times 6. So notice, like, it doesn't matter what you're squaring. Like if it's 12 divided by 2, if it's 6, you write the same thing twice. So we're going to look at some problems here. Like, what is 3 divided by 5 squared? Well, this means 3 divided by 5 times 3 divided by 5.
Yeah.
What is 3 times 3?
3 times 3 is 9.
What is 5 times 5?
25.
Perfect. Now, look at this original thing. Could you have just squared 3 to get 9?
Yeah.
And could you have squared 5 to get 25?
Yeah.
Absolutely. So let's look at another problem here. What is 4 divided by 7 squared? Well, you can square the 4. What is 4 times 4?
4 times 4 is 16.
What is 7 squared? What is 7 times 7?
7 times 7.
Yes.
7 times 7 is 84.
Try one more time. 7 times 7.
Oh, okay. That is going to be 49.
49. Perfect. Good.
Sorry about that.
No problem. Let's try one just a slightly bit more difficult here. What is 13 over 12 squared? What is 13 over 12 squared? So what is 13 squared? What is 12 squared?
What is 12 squared?
What is 13 squared? What is 12 squared? Yes.
And 13 times 13 is 169.
Yes.
12
12
times
squared?
12 is 144.
Perfect. Excellent. All right. Does your dad want to have any dialogue with me tonight? Does he want to get any feedback from today's lesson? Or do you want to stop here?
So we can stop here.
Okay. Do you know if your dad wants to have a talk, if he's available or not? It doesn't, it's
So thank you, Matthew.
Yeah, you're welcome.
Yeah, Dad. He's coming.
Great.
Hello.
Hi, Dr. Pythagorean.
Yeah.
So we worked on 2 things tonight. We worked on the Pythagorean theorem, and Sourish is really showing a really good, he's really paying attention. He's doing a lot better than during the school year.
Good.
Especially the last few lessons. He's really focused and doing the problems, and I'm really pleased. So I just thought you should know that he's really, it's clear to me he's trying his best here, and he's doing more problems on his own than ever. So
Great. Yeah. Thanks for letting me know. I think, that's a very positive sign.
yes. And then just the other thing, we're working on just some more numbers practice with multiplication, squaring, solving equations, stuff like that. But yeah, he's doing great. I did this, you're in the medical field. I mean, doing some outdoor stuff each day, that just helps the brain to get going, and being out in the sunlight. I mean, all that stuff's really great for kids to do as part of learning. So maybe keep them going in sports, if that's an option for you guys. That'd be
Well, I think, I don't know whether you want to continue next week or not. Maybe we'll
Okay.
take break next week.
Okay.
So the following week we'll see how it,
Okay. Yeah.
so
Yeah. No, that's awesome. But yeah, you should be proud of your son. He's really, I can just tell he's putting in the effort. So I hope it continues through the rest of the summer because it's been great. It's really been fun to work with him.
yeah,
last
I
few
think
weeks.
this will help in 10th grade,
Absolutely. Absolutely.
Yeah,
So,
so,
well, that's
okay,
all I've
very good.
got. We got another lesson on Thursday. We'll just keep going and we'll continue working on concepts from geometry.
Okay, great. Thank you.
You're welcome. Sourish, have a great night.
Yep, bye.
Bye now.